What's up, guys? So today we're gonna have an education lesson. There's a lot of people that are actually curious on this topic, and this is the last video I posted of sliding a Ford Edge off a bed. Had questions about, if it would harm the transmission or cause damage to the vehicle, and the quickest and easy answer to that is no, it won't. And so we're going to talk about that today. And we're going to use two vehicles I got here. This is a Nissan. This is a front-wheel drive car. It's a two-wheel drive, so the front two wheels are your drive wheels. And we're going to use another example. This is a Toyota 4Runner. This is also a two-wheel drive vehicle. However, this one is a rear-wheel drive. And so we're going to get into a topic on that here in a minute in the explanation. So basically, when we go to slide a car up onto a tow truck, i.e. flatbed, we're going to pull on the vehicle. Now, there's a part inside a transmission. I'm going to set this up here. There's a part inside a transmission that's called a park paw. And there's a gear, big metal gear that spins, that connects into the main drive output on the transmission. Big metal gear, and that gear has teeth in certain spots around. So you can kind of see on the back of this. And so inside this transmission, there's actually a metal paw, and this is why it's called a park paw. Comes around, and it's spring retained. And it's got one tooth, and sometimes more than one, that come down. And what they do is they line up with the teeth on this gear. If you've ever tried to put a car in park while it's in motion, you'll notice it doesn't stop. It actually spins until it goes slow enough for this tooth to drop into one of the notches on that gear. This is, it's basically just jumping around. Once this tooth is locked into the spot on the gear, though, it's pretty strong. And this is actually, what will break if you're shoving a car or yanking on a car way too hard and the wheels start rolling. Basically, what you want to see is if we're dragging a car up, we want to see that the car doesn't move freely while it's being pulled in park. If it starts moving freely, then one of two things happened. This park paw, the little tooth on the end, broke off. Or it popped out, which can happen too, because these do wear, and it can, wearing will cause these to angle in, so sometimes they can pop out. If you've ever had an old Ford, you know this, or if you're not sure that thing's in park, you make sure because it starts rolling after you get out. That's usually a result of already worn to the park paw. Well, once that's engaged, when the car's sitting, it holds pretty firmly. So the only thing you really wind up doing by dragging a car, and I'm going to call it dragging, sliding, or whatever, but you're pulling a car without it rolling. The only thing you're really doing, at very least, is just wearing a very, very minuscule amount of the tire. Because what's going to release first, the friction of the tire to the pavement or the park paw? It takes less to break the friction of the tires than it does to snap that park paw. It's actually a really strong object. It's a little bit more fun on the all-wheel drive models because you got now 4 wheels. However, you've got differentials, and we're going to get into that. So this Nissan here is a two-wheel drive, front-wheel drive car. So in order for this car not to move when it's in park, both wheels need to be, on a surface where they're able to gain traction or friction and be prevented from moving the same direction. If I was to lift up one wheel here, the car would now technically be in neutral because it can roll. That's the only thing that's keeping it from rolling is that park paw. So once I take one wheel off the ground, now I can roll the vehicle because the other wheel will now free roll. This wheel will actually spin the opposite direction. That goes back into the differential gearing. So in a differential, the gears spin one way, but when they gain both wheels, they allow both wheels to lock and spin one direction. So that's kind of how the transmission works on this. So if one wheel can spin the opposite way, the other wheel can spin. They can spin opposite of each other, so you technically can pull this car forward. And in some videos, you'll see that where one wheel is moving, but the other wheel is not, or it's spinning backwards. So now you only have the friction of one wheel. And this happens a lot too in your all-wheel drives. So this one will do that. And these are directly connected through axles straight into the transmission. Now, when I brought up the 4Runner, I told you it's a little different. So the 4Runner here has a transmission. It's up front. But now this has a drive shaft that comes off the transmission and comes to a differential in the rear. So now we're back to the same part. We're doing basically the same premise here as we got here. If one wheel can spin opposite of the other one, this car will move. So if you're pulling this one wheel will start rolling forward, but the other wheel is going to spin backwards. So now you're only fighting the force of one wheel. But all that force is in the differential now, and the tires versus the transmission. So the transmission still stays locked in park because it's only actually locking the drive shaft from spinning. But inside the differential, things can spin opposite direction of each other. This is also why when you're jacking up a vehicle to change a tire and you're picking up a drive wheel, or realistically, we recommend you put the parking brake on any time you're going to lift a car up. But especially if you're going to pick up a drive wheel, like a front wheel on this or a back wheel on this, you do need to set that parking brake because you're now putting the vehicle basically into neutral just by lifting that one wheel. All-wheel drives kind of work on the same premise. Say this Nissan was an all-wheel drive. Well, now we're just going to have these connected by drive shafts to the transmission, which is basically like a differential in itself in the transmission, allowing one wheel to stop and one wheel to spin. So as long as they're both firmly planted and kept from moving, the car can't go anywhere. This is also why they tell you to put your e-brake on when you're parked on a hill, because you're counting slippage. It is easier to slide a car and break traction on a tire than it is for it to roll. So a lot of times cars will slide, not roll. But if this was to be an all-wheel drive, then it would be the same premise as this 4Runner. It would have a drive shaft going to the back. There would be a differential back there, and it would do the same thing. So if I had to pull this car, say this car was an all-wheel drive, and I had to slide this car up on my deck, I only need to break traction on two wheels. Doesn't matter if they're on the same side or other, but they need to be opposite of each other. One on the front, one on the back. Easiest trick to doing this, and this makes it absolutely effortless, soap. So one thing I carry on the truck here, and this is what I carry, even water. Anything that helps break the traction. One thing I carry on here, and I kind of keep it tucked back here, is I got a big bottle of soap. And I'm not going to pull it out because it has a logo, and I'm not advertising for those guys, but I got a big bottle of soap. So an easy way to do that is I'll put a little trail behind the wheels. And if you watch the other video, you saw the car slid down for the most part. It kind of gave me a little resistance. Once it hit the ground, that was because it met that concrete surface, which gave it a bit more traction. But once that traction broke, it still continued to slide. And that's all you're really doing. So when somebody asks me, is this going to hurt the car? Realistically, no, it's not. It's not going to hurt the car as long as the parking paw stays engaged. Now, in order to break that parking paw while we're doing the towing, I'd have to take this truck and I'd literally have to back up 10, 15 miles an hour and ram the car with it in order to do that. So by tugging on it, even though it doesn't look gentle, it really isn't hurting anything. I know people will comment, oh, it's bad, it's bad, it's bad. Now, there are some cars you don't want to do this to. And in the other video, somebody actually did bring it up. The Mercedes-Benz 4MATICs, or, AMG 4MATIC cars. Now, the reason why this is not necessarily a good idea on those cars is not so much that you're going to hurt anything with the drivetrain, but there are sensors in there that are calibrated while the car is moving and when it's stationary. And so when you move the wheels, because yet again, the wheels will rotate as you're dragging or sliding or whatever, they're going to move. And it can cause the little gears that line up with those sensors to move and the sensors to basically lose calibration. That's what that is. Some people have said it will cause damage to a computer module. Others say you'll just have to reprogram the car. With it being a Mercedes, though, you have to understand those cars are finicky pieces of shit to begin with. So you want to be careful. Can it still be done? Yes. You just have to be a little bit more gentle on those, I guess, finesse. Now, another tool that is available, These things absolutely suck though for trying to go up the bed, because once you hit this lip on the ground, because this doesn't sit perfectly flat to the ground. It's got a bit of a lip. So once they hit this, they love to pop out from under the wheels. These weren't really designed for loading cars up onto a deck. These are called Go Jacks. Originally, these came out as a way to move cars around in a body shop or a mechanic shop on a flat level surface, a smooth surface too. These wheels are not good for using on asphalt. They were designed for smooth concrete. The original idea was for being able to move cars around inside a shop. You can put these under the tires and put 4 of them under there, and you basically got shopping cart wheels under the whole car, and you can move it any which way. However, you need a couple of people because you want to control the vehicle from hitting things. See if I can grab one without having to start this truck up. Another commenter said, well, why didn't you just use, or they make these plastic blocks, they're cheap, you can use these to help. What they're talking about is this. This is called a tire skate. Basically what this is a plastic block, and you shove it under the tire, and I'll show you kind of how here. Obviously, you're not going to do it on a flatbed. Shove it under the tire, so when you pull, the tire lifts up onto this. And what this basically does, it just does the same thing that soap and everything else does. It helps you break traction. However, now you've got this piece kind of grinding in. These work great on steel. Somebody, I think, said they had a smooth deck. Smooth decks are even easier to slide or drag things up. Diamond plate's a little bit more because you have diamond plate. And diamond plate naturally wants to grab things. There's actually soap residue here as I'm rubbing it across. Diamond plate wants to grip into things. That's why a lot of trucks now are being diamond plated. It's more so for when you're walking on the deck. You don't slip and fall. It's not so much for the cars. But this stuff is low enough too that it basically, it's still steel. Steel is a very slippery surface to reduce traction. If you think of like a train, it has steel wheels on steel rails. And when a train is pulling something heavy, those wheels slip. So what they do is they actually have a tube that goes in front of the wheel, and it blows sand in front of it. And that creates grit on the two steel surfaces in order to allow there to be friction between the two materials. But without that, it's a very slippery surface. Steel is, a very slippery surface. The great thing about that is that once I get tires up to the edge here, they slide perfectly. Because they break traction. The most resistance is the actual roadway surface, the asphalt or whatever. And even that, once it's compromised by water or soap or anything like that, cars slide. I mean, you have to think too that, like when it rains, you hit your brakes or people hydroplane. That's the same thing. They're breaking traction, and now they're sliding or slipping. So it's the same thing here. It's the same premise. So back to, the whole thing with the transmission and stuff like that. When you're tugging on it with one of these, the most thing you actually really have to worry about is just what you're hooked up to. Because if you're going to cause damage to a vehicle dragging, you're more likely going to damage, not the transmission when it's in park, but you're more likely going to damage whatever you're hooked up to if you're not hooked up to the right item. Now I'll show you here if I can get a good view of it on this 4Runner. Let's see here. Let me see if I can turn my flashlight on while we're recording. All right, I'm going to pause this real quick so I can do that. Okay, so I can't do that. At least not when I'm paused. I can turn it on when this is stopped, but anyway. So here's what I'm going to do. I'm going to use my tablet for a flashlight. I think that's going to work better. Just as soon as I can do it. Okay, so I'm going to show you here. What we generally will hook those hooks up to. Now, this is, for the most part, the same thing in a lot of vehicles. However, these do differ in characteristics. This is called a lower control arm. Or as we basically dummy call them A-arms. And the reason that is because, let me get underneath here, show you a little better. Now, the reason is because if you see that, it's kind of in the shape of an A as it goes outward. They're typically, referred to as A-arms or control arms, or axles, as some people call them, even though it's not an axle. Um, what I explain to people is this is a very strong component on the front of your vehicle. The reason why this is a strong component on the front of your vehicle, and it has to be, is because it is transferring all the weight of the vehicle in this corner to the wheel. This one, and there should be an upper one. There is. It's all the way up top. Another wishbone. That's really actually just for keeping the wheel straight. It takes some force, but most of the force is on this. And that's why you see this thing so beefy and built the way it is. So when we're going to pull the vehicle, we're going to put that hook, that big J hook, they're called J hooks because they look like a J. We're going to put that hook on here. Now, where you place that hook is very critical because if you put it in the wrong place, you can break stuff. See that torsion bar there, or little sway connecting link? If it hits that, it can snap that off because that's just thin little material. So I'm going to try to put that hook right here in this joint. The reason I'm going to do that is because that's a perfect spot. It's right next to the wheel. It's where everything meets up. It's the strongest place here. Sometimes you can kind of get closer inside here and put it around here. I don't really like to do that so much because you see this bracket here as well as this thing. They can get stuck, or they can, well, in this one it's not going to bang anything because this is pretty good steel right here. But they can get stuck or cause issues. So I'll go right here. This clears everything else. It stays there. It V's out and it keeps it in place. And that's, I'm pulling from now the strongest part of the vehicle. They do have these. These are pull hooks and tie down points on this 4Runner. However, we're not really going to use these for pulling on. This piece of steel here, even though it's got, maybe a good 3/16 of an inch or 1/4 inch thickness, this is good for straightforward. However, when you're pulling with a cable, it's generally you want to pull inward. It's going to bend these. We use these for tie downs. These are called T-hook slots, as they're an oval shape, and there's a T-style hook that actually goes in and locks in, or a mini J. This is a pull hook, but the problem with this is there's not one on the other side, so if you try pulling from this side, it's going to off-center and turn the vehicle sideways. So we're not going to pull from that. We're typically going to use these just for securement. Now, the reason I say you have to be careful here is because there are other components in the way. See that bar right there, this bar? That is called a tie rod. It's a bar that connects the steering rack to the wheel. So when you turn the wheel, that bar moves in, or when you turn the steering wheel, that bar moves in and out of the rack and pulls in and out on this hub, which moves and steers the wheels. Those are not meant to be pulled on. When you're hooking up here, if you're not careful, because some of these, they put them right next to this guy. Right behind, but right next to them. Some of the older Lexuses and Infinities were really notorious for this. And if you weren't paying attention, you're thinking you're hooking onto this, but you're actually 2 inches further back and you just hooked onto that. If you're going to pull on that thing, one of two things is going to happen. It's going to bend or it's going to snap. The least it's going to bend. And you're going to basically destroy that thing and they're going to have to replace it. Stern's going to be off. So that's the part you have to watch out for, and a lot of guys don't realize that. What I like to do is when I put my hooks on these components, I already know what I'm going to hook to, so I'm not really looking. But what I will do is I will put the hook on, I will reach around from the backside of the tire, and I will feel where my hook is and what I'm attached to. I know by feel if I'm attached to the right component or not. It's also another way I can reach in and determine if this is a 4-wheel drive, a front-wheel drive, or a rear-wheel drive, as I will get in here and I will feel. As you see, there is no axle going across. So this one is actually just a 2-wheel drive. But that's ideally where we're going to hook up to. Now, we can go to, let's see here. We can go to another vehicle. Somebody may bring this up here about the aluminum control arms on the front of some of these vehicles. And there are vehicles out there, they design that same piece, but they design it out of aluminum. It may not be an A-frame, it may be a straight piece across. And there's mixed opinions on that, whether you should hook to that or not. Here's the deal with that. That piece has to be made strong in order to do the same thing that A-arm is doing. It has to be able to hold the weight and forces of the vehicle, as well as combat the forces of the vehicle driving. There's a lot of force that gets put on that piece while the vehicle is in motion down the road. So it has to be strong enough to sustain that. Otherwise, it would simply break. So when I hook up to something like that and somebody freaks out and they're like, oh no, you can't do it, it's going to break it. No, it's not. And the reason it's not going to break it is because the same premise and rule applies when you're driving. It's not going to snap it because it has to be built and engineered strong enough to hold the forces of the vehicle going down the roadway. Granted, it's not being pulled on, but it's being subjected to a lot of forces of up and down motion and sharp impacts. When you hit bumps and stuff in the roadways, it actually is subjected to more force than it being pulled on. Can you scratch it? That all depends. These hooks are generally designed with a rounded edge. These are forged, but they're designed rounded. So these aren't really going to scratch it. Even if they slide on it, they're not going to scratch it. BMWs are the worst for this. I've had people tell me flat out, you need to use the eye bolt. What is an eye bolt? Now I got to figure out what I'm going to title this video. Alright. I hate these things. They're absolutely horrible. But still keep them around because they come in handy for other uses. Will I trust them 100%? Hell no. Okay, so what an eye bolt is I've got a whole array of them. These are called eye bolts. Many different vehicles, these are like BMWs and Audis. Many different vehicles have a hole. This is actually a Chevy, surprisingly. But look how thin that thing is. Many vehicles have a hole in the front or rear bumper cover, actually. And there's a threaded slot in the reinforcement of the bumper. Actually, let's go back to this 4Runner. I can show you what that is. I think this one still has it. Or maybe this Toyota has it. Something it doesn't have. See, like this is called a bumper cover. This is a piece of plastic it goes over. And what's behind it is that bar right here, this metal bar. That is called the reinforcer. That's the actual bumper. That's the metal part that's designed to absorb the impact. Yeah, okay, so this one doesn't have it. But basically, it's too bad I don't got a car that has it removed. So as you can see here, this is where the bumper would mount to, or the bumper reinforcer would mount to. In most cases, it's going to be held by a steel plate, kind of like this. This is a bit stronger than the one that's on the reinforcer. But a stamped steel plate, an arm coming out, and then a bar going across. And it's going to be held in place generally by 3 bolts on each side. Okay, well now, a lot of those cars that those eye bolts go to, they make those out of aluminum. Now we know that aluminum can be a strong material, but it can also be a very weak material. And for a part that's designed to take an impact, it's actually designed to crumble and smash. So now we're going to call that a weak material. If you want to know what that is, go back and look at search one of my older videos of why I don't use towing eye bolts. And there's a demonstration there of a Lexus reinforcer. The problem with it is that those flanges that bolt to the car, like I just showed you in that 4Runner, like on the Lexus, they just use press-in, stamped-in, threaded inserts that the bolts go into, and those have a tendency to rip out. Your weakest part on those is actually where it bolts to the vehicle. And you're putting all that strain and stress on that one part. Do I think that's as strong to pull onto as those control arms are? No. I think the control arms are our absolute strongest part to pull onto from the vehicle, set aside from pulling on the wheels, but we usually try to allow the wheels to roll when we're pulling them up. So this is obviously an array of different eye bolts. You can see that they're made of different materials. This is forged aluminum. Or this is not forged aluminum. This is what's called die casted or pour forged, and then it's machined. They pour it into a thing. They pour it into a mold, and then they stamp out this, so it kind of stamps it down. However, this is steel. I'll take that back. This is steel, but this is still made out of some shitty metal. Most of the time, it's recycled iron and whatnot. So these can be strong, but they can also break. This is for Nissan or Infiniti. You see, they got a pretty good sized thread here, pretty aggressive thread, nice grip. This is the BMW ones, and these were the ones that were notorious for actually ripping out. The threads would strip out. It's almost like an Acme thread. How's my camera? Focus. Focus, you fuck. Kind of like an Acme thread. I've had parts that have had this. These threads are notorious for stripping. And then we've got this one here, which is, this is Toyota. It's almost the size of the shaft. Actually, I want to say it's probably a little bigger than the shaft on the threads. They've gone with some pretty good fine threads, so this thing's going to have a lot of area to bite to. It's probably a little better with the fine threads. This is basically a rod that's been threaded with a welded eye on the end, so if this was going to break, I would say it'd probably be right here where the welds are. It's usually where the weakest part is. And then this is another, I think this one, no, this one's out of steel too. These are all, for the most part, steel, except these BMW ones. And these are like BMW, Audi. What did I put for this one? This is BMW. No, that's steel. I thought they were aluminum, but no, they're not. That's steel. This is Audi. They're almost the same, however, the threads are a bit different. That right there is an absolute horrid thread. Very little contact. It's aligned for deep grooves, but you don't have each thread, and the threads themselves are what's holding the pressure. They are a bit thicker, but I would like to see, in these things, I would like to see something like this. Fine threads, the more the threads, the more surface area to grab to, and that's really where your strength is going to get versus something like this. Problem with these things is they make them in all kinds of different sizes, lengths, and threads, as well as some of these are proprietary, so they're a pain in the ass. I forget, I think this is Subaru or Volkswagen. And some of these even have left-hand threads. Like, actually, this one is a backwards thread. So it just gives you some kind of idea on these stupid things. Keep them around. Usually I use these to help out in recovery or something if I just need a good place to and I can't get to the other spots. Otherwise, they sit in here and collect dust. So back to what we were talking about. That is the basic fundamentals of dragging and sliding a car and why it doesn't really hurt the vehicle. Something good to have on the truck, which I don't have it on the truck right now, is actually WD-40. I've had cars where I've had to shake them off the bed. And the other video was me shaking it off the bed, that Ford Edge. I think it was an Edge or Escape, one of the two. WD-40. If I was to actually, instead of using the soap, I was to spray a trail of WD-40 behind the wheels, all it would have taken was one shake of the bed and the whole car would have slid perfectly off the bed until it hit the ground, because what's going to happen when it hits the ground, it's going to now wear that liquid away real fast and cause the vehicle to stop. I'll usually choose an area that's got a lot of space so I don't have to worry about it hitting anything in case anything doesn't work. But yeah, but once it hits the ground, it's not going anywhere. Another thing too, if you can put the parking brake on, that helps too, especially if it's a rear-wheel drive. Parking brakes lock up the rear wheels on pretty much every vehicle. At least every one I know they make here in California. Every vehicle, the parking brake locks the rear wheels. On a rear-wheel drive car, well, there you go. You're now taking all the load off the transmission or the differential, and you're putting it strictly on the brakes, which is even stronger. Like this tow truck here. Parking brake locks the rear wheels. Rear wheels are locked by the transmission. Same thing with this F-150. This is a two-wheel drive, but it's the same thing. I can get on here and show you the drive shaft portion. What I'm talking about there. Oh, maybe I can. Yeah, okay, you can see it. So you can see that tube right there. That's your drive shaft, and that goes to the transmission. But when you're dragging these things, all of it's actually going on back here, and this is the differential. And these gears can spin opposite of each other, and that will actually still stay stationary. That won't move. Curl out from under here, so. Well, not making this video totally crappily long. Hopefully I was able to educate some. I'm still going to figure out what I'm going to title this. Please remember to like, comment, subscribe if you haven't done so already. If you have, then thank you, and thanks for watching. If you have any more questions or want to, put opinions are everything. Great criticism is always accepted. Or comments, please feel free to put that in the comment box below, and I'll try to link a couple of those videos into here so you guys can look for them and see, what them for yourselves a bit more. So, thanks for watching. Y'all have a great day.